This is my audience for today, and let's get started. Take a look at this 3D printed metal. It feels like a normal finished object, but only a few hours before this, it didn't exist as a physical object. It was just stored on a computer. A 3D printer turns that information on a computer into a real project like this metal. Many people imagine that 3D printing is as simple as choosing an object and pressing printing, and that's it. But in reality, the printing is the final part of this whole process. Before we have planning, software, and carefully selecting the settings. This process is becoming important because the same basic technology can be used to create products, to create prototypes, and even more medical devices. I became interested in this topic because I bought my own 3D printer and learning how to prepare and print custom objects, including metals and prototypes like this. My purpose today is not to convince you to buy your printer. I simply want you to understand how 3D printing works. By the end of this pitch, you will understand how a 3D module is created and slicing software prepares the design and how the printing builds the final object. This is the metal, and let's get started. To begin, let us look at a digital module, because before the printing can make a physical object, it first needs a precise digital version of that object. The digital model determines the object shape, measurements, shape, and other details like this and how that's gonna work. And the rest of the project, the finish should look like. A model can be created from the beginning in a computer software, downloaded online on an online library in just printing, or producing by a scanner, a manual scanner that you can scan a piece and print. Computer software gives the designer the 100% control before the physical material, the measurements, the curves, the whole text, or anything you'd like to transform. For example, in my case, I prepared this medal with a name, different name. So overall, on the software, you can design anything, the thick, how big it is, and even different names and text. According to the National Institute of Standards and Technology, also known as NIST, additive manufacturing uses digital designs to create a three-dimensional product by building material layer by layer. Instead of cutting an object or a material and designing that. After the module is finished, it is commonly saved in two different files, STL or 3MF file. That file stores the geometric of the material to be sent to the slicer, which is the next software. At this point, the object exists only on the computer, and the next step is to translate that shape into instructions to the slicing or the printer software. Now that you understand how the object shape and measurements are created, the second step is to translate the model into detailed instructions to the printer. Usually, printers, they have their own software. This is done by slicing software. That's how that calls. The software divides the module into many thin horizontal layers almost like cutting the digital object in very, very large of stacks by extreme slicing thin. The slicer then creates the path to the printer follow for every layer, beginning at the bottom of the object and goes upward. In 2014 article titled How 3D Printer Works, the US Department of Energy explains that digital designs is divided into thin cross sections to printer knows exactly where the material must be placed. In this image, I'm gonna show you guys an image of a slicer and how that works. Let me show you. And this is a slicer. As you can see, there's very thin layers, very thin slicing areas, and you can see that start printing from here until the end of it. That's the slicer. Let's get back here. So the person preparing the print must choose on that software the settings that affect the final results, like layer weight control, like thickness, or each layer influencing how smooth, like this, and detail the surface will be. Infill inside how they gonna select the shape inside, controls the material placed inside of everything. A low infill can make the object faster or less, depending on the way you want, and how detailed you want can be faster or slower. Also, another settings, it's so important, is the temperature. The temperature match the type of material being used, and the software may also add temporary support structures to hold some areas that can be fell. So before starting a new print, I use the slicer preview to check for weak areas missing supports and unusual movements that could cause the object to fail. And you're gonna lose your whole project if that happens. You gotta restart. Once the settings and preview are look correct, the product is ready to send to print. Once that model is sliced and final is sliced, it's just click slice on the software and you're good to go. The settings have been checked. The printer can finally use those instructions to build the physical object one layer at a time. In common desktop filament printer, a spool-fed plastic filament is like a plastic filament into a nozzle, a hot nozzle that being hidden, soften the plastic, and the nozzle deposit onto the plate where it's going to be built. The nozzle move across the plate, then complete the first layer. It then rises a slide and creates the next layer, and so on. Each new layer bonds to the layer below, and the object slow grows from the bottom upward until the final shape to complete something like this. Because the printer may repeat these movements hundreds or thousands of times, even a small object can take several hours or days. The process also requires attention. A print can fail if the first layer does not stick on a plate, and you can lose your whole project for that. When the printer finishes, the object may still need time to cool down. The material needs to cool down a little bit, temporarily. Supports may need to be removed if you have added supports to it. The US Food and Drug Administration explains that 3D printed medical products can include implants, surgical instruments, dental restoration, and even external prosthetics. Those examples show that the same basic can create a simple customized medal like this, or a higher level medical product. The purpose changes, but the sequence of digital designing, slicing, layer by layer, and sending to the printer is the same, is similar. In conclusion, the object I showed you at the beginning, this one, did not simply appear when someone pressed print. It began as a digital model that defined the shape and measurements, and then slicing software then divide this module into layers, converting into instructions to the printer to print a layer by layer at a time. And then understanding this process changed the way I look at 3D printed objects, because I now recognize how much planning happens before the machine even begins moving. The printer is important, but the successful results depend on the design and the preparation and the decision made before and during the print. The most interesting part for me for 3D printing is not only the machine can create an object, but then an idea moving from a computer screen, anything you can imagine it on your hands. What began as a digital information is now something real. This is 3D printing.